One of the things that's important to understand with these forms, with these equations, is that numbers are just numbers. Now, we want to have nice, pretty numbers. In the last example, we had 9 and 25, and c squared was 16, which made c equal 4. Nice, perfect, pretty, everybody was happy. Things are not going to be nearly as happy here. But you know what? I think we're going to be okay. I'm just asking you to trust me, right? So if this is my a squared, that means that my a value will be the square root of 20, which simplifies to be 2 square roots of 5. And here, that means my b value would be the square root of 28, which reduces to be 2 times the square root of 7. So these aren't pretty numbers. And so my graph is not going to look super pretty, and I may not even draw an x and y grid, because where am I going to put these numbers, right? So let's do this. We know from the form that our center is easily picked off as being the opposite of this, positive 7, and the opposite of that, positive 3. And we know it's going to be 7, 3 because we picked the 7 because it's with the x coordinate, or with the x value, so that's the x coordinate. The 3 is with the y, so that's my y coordinate. Okay? So if we were to draw a quick little picture, here is my center at 7, 3. I'm stretched more in the y direction than I am the x direction because of the 28 being bigger than 20, right? Now, 2 square roots of 7, who really knows how far that is? Without, I mean, you have to go to a calculator and get the decimal. I don't really care. So I will be doing this. So be up and down. And this is going to be a total of 2 square roots of 7 for each of these. And then I'll be stretched in the x direction on either side by 2 square roots of 5. So this is 2 square roots of 5 here, and 2 square roots of 5 here. All right, I'm just going to do my best to draw a little picture. And again, this picture is not going to be accurate. It's just here to help me see what's going on, to give me a good visual representation of this equation. And hopefully it'll help me answer some questions. So right away, we could talk about vertices, we could do domain and range, but I want to hold off on that. Let's find the c value first. So c squared is going to be the difference between these guys. So 28 minus 20 means that c squared is equal to 8. And when you take the square root of that, you have 2 square roots of 2. So that is how far away we are from our center. Since we are stretched in the y direction, that means that the foci will have the same x value, same x value, 7, still thinking we were at the origin, but then we're going to take our y value and we'll go up and down 2 square roots of 2 to come up with the coordinates for the foci. And we're going to do something very similar when it comes to the vertices. So the vertices, x is going to be 7, y is 3, but now you're up and down, and this is where you look at the stretch. So if the denominator had been 25, you'd say up and down 5, okay? But here it's a square root, and we don't want to go to a calculator. We want answers to be exact. So for this vertical direction, for this vertical stretch, 3 is the central point. You're going both up and down 2 square roots of 7 based on that value that we have right there. And since we're talking about the vertices, let's talk about the length of the major axis. Well, remember, the length of the major axis is going to be double the larger of these two numbers. So we know that the b value is along our major axis. We double that and we have 4 square roots of 7. And then the length of the minor axis will be double this guy right here. So that's going to be, not that, 4 square roots of 5. And this is where we also talked about the endpoints of the minor axis. So for those endpoints, the minor axis is going in the x direction. So it's the x coordinate that's changing. The x starts at 7. You're going to the right and to the left by this smaller number. So 2 square roots of 5. And the y coordinate, 3, stays the same. So those are the endpoints of the minor axis. Again, it's going in the x direction because the number underneath the x is smaller than that that's underneath the y. All right, so now we need to talk about the domain and the range. So my domain, well, how far to the left do I get? And that's where you look at here for you look at the endpoints of the minor axis, because the x is stretched in the minor way. So on the left, you have 7 minus 2 square roots of 5. And on the right, it's 7 plus 2 square roots of 5. For the range, since the range is affected along the major axis, we look at the vertices here. So the lowest we get is 3 minus 2 square roots of 7. And the highest is 3 plus 2 square roots of 7. All right? So again, look at your picture. If you were to do these ordered pairs, this one down here is 7, comma, 3 minus 2 square roots of 7. And the one here is 7, comma, 3 plus 2 square roots of 7. Right? So our range goes from here at the bottom to there at the top. And again, drawing the picture is going to help us out tremendously. And that is going to inform you about how you're supposed to move up, down, left, and right, how you're stretched in the x and the y direction, your major axis, your minor axis, even if these numbers were a lot larger, right? So if this had said x minus 37, for example, the only thing that would change would be the center and the beginning of these ordered pairs for the foci, the vertices, and then your domain and range and endpoints, right? But it doesn't actually change the math. So if I made this, say, 27, right? That means the center would be at 27, comma 3. The foci would be at 27, comma 3 plus or minus 2 square roots of 2. The vertices at 27, comma, right? And so endpoints would be 27, 27, 27. That's the only thing that would change. Your math wouldn't change. You didn't change your denominator, so the C value doesn't change. The way that you shift up, down, left, and right didn't change. The only thing that changed was the x coordinate for the center, which means your reference point. So then you change everything else accordingly, right? So the math and all the stuff that we did is still going to be the same no matter how big the numbers are, right? So I just want you to keep that in mind so that you hopefully don't become overwhelmed. You can do this. Take your time, draw your picture, and make sure you know how to get your A, B, and C, and you're going to be fine.